Hey everyone, and welcome to the third video of this math library programming series. Um, so, so we are just about done with this file. I just have one more function that is thought of that I think is good to add. I don't know why I didn't add this, but I think this function is going to be very useful um, when we do discrete math potentially later. So, so this is the factorial of of a number. So we're not doing factorials of decimals. We're only doing integers. So yeah, let's. So 0 factorial is 1, and otherwise we'll just find to n times factorial of n minus 1. So what happens when we get a negative number? It'll just cause an error, which is good because you can't find the factorial of a negative number. So we do factorial of 4, that should be 24. And we do factorial of negative 1, should give us an error. There we go. Or if we want to be a bit more cautious with this, we'll just have this program throw its own exception so we won't get a Stack Overflow error. Awkward if it's not. Yep, it's a Stack Overflow error. New exception. All right, so that's the factorial function. And let's get started with a new file. So these next files are going to be they're going to surround linear algebra. So this is like the whole reason why I am uh, I'm, I'm doing this series, and that's because we need linear algebra to do what we will do in the future when we use decimals again. So let's start with the vector. So we're going to do two huge classes. We're going to do a vector and a matrix. We'll spend a few days on the vectors. I'm thinking 2 weeks. We might need more, depending on what we need to do. We'll just do the basics for now. So I'm gonna need try and think here. Pretty much we're just gonna need the size. And then we're gonna need some sort of representation of a vector. So make it a size double. Make it a double array. think that is it for the setup. In fact, let's do for what is initialize it to the zero vector? Uh, put all right, and then we'll do the basic functions. Let's do maybe scale. I'll do these two for now, and then let's do. I'm thinking about calling this either magnitude or length. I'm gonna call this magnitude because the length might sound like something else, like as in how many elements are in the vector. And then do just magnitude. It's also public. Do and let's do dot. So I'll do these today, and next time um we'll add more if I come with any. Otherwise, we'll just move on to we'll start doing matrices. All right. So add we're gonna need another vector to add it to. So let's. Oh, okay. We should make sure that the vectors are the same size. Okay, let's see if. Okay, so it looks like we should have our own size variable. Let's see if they're not the same size, then we have a problem. Okay, then otherwise we can add these things one by one. So Right, and then with scale, how much to scale it by. So we're gonna go with the way we scale, we're gonna go through each element in the vector, and then we're gonna multiply by that. And magnitude is where we're going to need the square root function and the square function. So return. Can we get by? Okay, I want to keep it simple. So we need to import our functions, and then let's make a sum set equal to 0, and then we're going to sum of each element. Well, you know what? The vector assumes that actually no, that's not going to be a problem. It's okay. Yeah, this assumes that what is it? The tail of the vector starts at the origin. That's all right. We should make a note of that. Okay, so for for each element in the vector, I'm gonna multiply by the square of that number, and I'm going to return square root of that value. Oh, I know we don't have a square root function. Okay, give me one moment. I want to make a square root function. I'll be right back. All right, so I have a square root function now. So yeah, I haven't tested it out yet. I will in a minute. First, let's finish these functions, and then we'll see how this thing works. So normalizer first, we'll need the magnitude. And then we'll iterate through each element in the vector, and then we'll divide that by the magnitude. So let's go through. And dot, we need another vector to dot it with. So let's take another vector. and we're going to do something similar to what we do with the addition function. So, so if they're not the same size, then we can't dot them. Okay, and then let's make. Oh, wait, dot product can have decimals. Let's do double. Call it sum for now. I don't have a better name for it. All right, so let's test these guys out. So first we'll test the square root function. Oh, what happened here? What if we did this instead? Really? Do I have this throwing? Okay, guess we're surrounding it. So let's give. Okay. This error threshold. I guess this is how it's going to work. How accurate is it with 2? That is really strange. I'm gonna have a look at this and see what's going on because something's not coming out right. So it turns out I had these numbers mixed up. That was it. So I'm gonna fix that here, or do something stupid again. Now let's see how this does. All right, pretty good. So now let's test our vector object. Import linear algebra. That's good. We should have a method that converts that has a string representation of this so they can print it out. Strings. All right, so let's do vector 3. Okay, now let's print out this vector. Okay, so far so good. And then, oh, we forgot to have a way to edit this vector. Okay, this is going to, it's strange. I'm going to make this one public so we can add this straight up. Only catch is, so this has to happen first before we can do things like this. So vector, that's a better idea. It's bad programming practice anyways, so we might as well not do it. So we're going to set the index to where we want. So this is basically all we're doing. This, so vector dot set 0, make this 1. Set 1 to maybe negative 3.2. And the last one to maybe 6. Now we print out, and there we go. So let's try another vector. This one is 7. All right, so let's do vector dot add. Well, wonder how this happened. Oh, okay, that's okay. You're pretty out vector. Okay, so we start with 1. Let's print that again. Okay, 1 and 7, that makes 8. Think of 3.2 plus 2, that is negative 1.2. And 6 minus 1.1, that is 0.9. Yep, there we go. So actually, let's find the magnitude of a vector. Do something easy. There should be a 3, 4, 5 triangle. Should be 5, hopefully, and it is. Right. So yeah, you can play around with that. Um, and as always, like, let me know if you have any questions about how something works. Let's see, what else should we test? I'll test one more function. Let's do dot. Course isn't is try catch. Well, because we wrote it that way, because just in case someone decides to dot two vectors of 2 different size, we need to catch that. Is this really 3 times 1? 3. Okay, this one's 3. This is 8. Add them together, you get 11. All right. So yeah, that's pretty much it. So yeah, if you like this video, do leave a like, and I'll see you next time.